So what is displacement? Displacement is difference of position. So we can see right here, that is the symbol that I'm going to be using as displacement. Some people will use like S, for example. So if you want to use that as well, whatever you want to use. And then delta D here, that means, so the delta, the triangle in front, which I kind of drew up at the top here, that means difference. And then the D here is position, and then the arrow there means it's a vector. So we can see right here, this is an example of what you might write as displacement. So you can see displacement equals 10 meters to the north. So you can see the vector right there, the 10 meters right, or the north right there, as a vector, because it's a direction. So the reason why displacement is a vector is because every time you're writing displacement, you have to have a direction there. So either north, you can do like forward, so like F, W, D as forward, or east, south, backwards, whatever it is, or up, down, whatever you want to use to describe the motion, or describe, not the motion, but the difference of position. And then, there you go, so I'll just have an example here. So if you start right here, so this is 1, and then you move all the way here to 2, then you can say the displacement was forward. That's the direction, like forward right here. Or if this is in the east direction, you can say east. But then if you move over here, and then you come back around, and now you're right here, and that is the second position, then now your displacement is backwards, assuming you make this forward. If you make that forward, then this would be backwards, or it could be west as well, or whatever direction you want to make it. So a way to find displacement, you could use this equation right here. You can also use this one. They're the same things. So this one is delta D equals dF, which is final position. So position final, subtract position initial. And then this one is the same thing, but it's position 2, which is final position, subtract position 1, which is just initial position, just written in another way. And then I have an example right here on how to find displacement here. So you're standing 5 meters, we're going to make it east, so always set a direction. So this is east, we're going to make east positive. I'll explain more about what that means later. So you're 5 meters east of a tree, and then you move, so you're now 7 meters west of a tree. And now you're trying to find the displacement. So we have to find, or we have to give our variables values here. So this right here, the start position, that's di. So di, right there, equals, it's 5 meters, and then remember, for all vectors, so because there's an arrow at the top, it's a vector, so you have to put a direction. So we're going to say east. 5 meters east. And then this one right here, df, is going to be 7 meters west. West. There we go. So now, the problem is, if we try to put these two values in the equation, how do you subtract west with east, right? You can't really do that. So you have to convert the east and the west here to either positive or negative. So because we made east positive, the east value is going to turn positive, and the west value is going to turn negative. So di would now become 5 meters positive. 5 meters positive. And df here is now going to become 7 meters negative. Because see how it's west, so it's negative, and then east is positive. And then those are the two values we're going to put into the equation. So then we're going to say delta D, remember the arrow, equals, so df, which is 7 meters, subtract 5 meters. And then delta D is going to equal negative 12 meters. But now, remember, so because it's a vector, it always has to have a direction here. So we take this negative and we convert that back into a direction. So it becomes delta D equals, and then since it's negative, remember from up here, so since east is positive, negative will be west. So west. And that's how we would find displacement using two positions. You can watch my next video to figure out how to do it using velocity instead, velocity and time.